Good afternoon, students. I am Mrs. Kanimuri, handling physics subject. I welcome you all for a Neet crash course. Let us now start the first unit. It is unit on dimensions. Okay. In physics, we are using many measurements and units. If you go for somewhere, say for example, go for a shop, textile shop, buy some clothes. Okay, so they are readily asking Good afternoon, students. I am Mrs. Kanimori, handling physics. Today, we are see about the unit, that is unit and dimension. Day-to-day life la நம்ம நிறைய units and measurements use பண்றோம். இதுல நம்ம frequent-ஆ யூஸ் பண்றது அப்படின்னு பார்த்தோம்னா daily from the morning itself நம்ம milk வாங்குறோம். So அதுல நம்ம கடையில போய் கேட்கும்போது ஒரு 100 ml 500 ml அப்படிதான் நம்ம கேட்கிறோம், ரைட்டா? சோ இதுல ml அப்படின்றது நம்மளோட யூனிட். சோ இப்போ மெஷர்மெண்ட்ஸ் அப்படிங்கும் போது இப்ப நம்ம 100 ml 200 ml 500 ml அந்த மாதிரி நம்ம கேட்கிறோம் இல்லையா, குவான்டிட்டி, அதுதான் தட் இஸ் நத்திங் பட் மெஷர்மெண்ட். நம்ம பிசிக்ஸ்ல நிறைய பிசிக்கல் குவான்டிட்டிஸ் இருக்கு. அந்த பிசிக்கல் குவான்டிட்டிஸ்க்கெல்லாம் நம்ம டிரைவ் பண்றதுக்கு மெயினா நம்மளோட யூனிட்ஸ் அப்படின்றது தேவை. ஓகே, சோ பிசிக்கல் யூனிட்ஸ், பிசிக்கல் குவான்டிட்டி, எந்த பிசிக்கல் குவான்டிட்டியா இருந்தாலும் அதை மெஷர் பண்றதுக்கு நம்மளுக்கு ஏதாவது ஒரு நம்பர் தேவை. அது மட்டும் இல்லாம ஒரு பர்டிகுலர் யூனிட் அப்படின்றது ரொம்ப இம்பார்ட்டன்ட். ஓகே, சோ இப்போ நம்ம ஒரு பென்சில் எடுக்கிறோம். சோ ஒரு பென்சிலோட மீட்டர், தட் இஸ் நம்ம லென்த் வந்து ஒரு 10 மீட்டர் ஒரு அப்படின்னு மெஷர் பண்றோம் அப்படின்னா 10 அப்படின்றது நம்மளோட நம்பர். அண்ட் லென்த் வந்து நம்ம எந்த யூனிட்ல மெஷர் பண்ணுவோம், மீட்டர். சோ மீட்டர். ஓகே, சோ திஸ் இஸ் த physical quantity. Here I am taking length. ஓகே, சோ ஒரு பென்சில் எடுத்துட்டு அது ஒரு 10 மீட்டர் நீளமா இருக்கிறத நம்ம கன்சிடர் பண்ணோம் அப்படின்னா நம்மளுக்கு இந்த 10 அப்படின்றது எதை மென்ஷன் பண்ணும் அப்படின்னா நம்பரை மென்ஷன் பண்ணுது. ஓகே, அதுல மீட்டர் அப்படின்றது எதை மென்ஷன் பண்ணுது அப்படின்னா கரஸ்பாண்டிங் யூனிட்டை மென்ஷன் பண்ணுது. ஓகே, சோ இந்த மாதிரி நிறைய பிசிக்கல் குவான்டிட்டிஸ் இருக்குது. ஓகே, சோ லென்த், மாஸ், டைம், இதெல்லாம் வேரியஸ் பிசிக்கல் குவான்டிட்டிஸ். ஓகே, சோ ஃபர்ஸ்ட் in olden people they are using only the 3 fundamental physical quantities. Okay, என்னெல்லாம் அப்படின்னு பார்த்தோம்னா mass, length, then time. இந்த 3 physical quantities வச்சுதான் என்ன பண்ணிட்டு இருந்தாங்கன்னா various physical units மெஷர் பண்ணிட்டு இருந்தாங்க. ஓகே, ரைட். சோ லேட்டர் ஆன் என்ன பண்ணாங்கன்னா நிறைய கண்ட்ரீஸ்ல இந்த மாதிரி மாஸ், லென்த், டைம் கால்குலேட் பண்றதுக்கு ஒரு யூனிட்ஸை யூஸ் பண்ணதுனால நம்மளுக்கு நிறைய கன்ஃபியூஷன்ஸ் வந்தது. சோ அதனால எல்லாமே ஓவராலா சேர்த்தி மாஸ் அப்படின்னா ஒரே ஒரு குவான்டிட்டியில மட்டும்தான் நம்ம ஒரே ஒரு யூனிட்ல மட்டும்தான் மென்ஷன் பண்ணணும் அப்படின்னு சொல்லிட்டு ஒரு கன்க்ளூஷனுக்கு வந்தாங்க. சோ அப்படி நம்மளுக்கு டிரைவ் பண்ணி கொடுத்த யூனிட்ஸ் தான் என்னது அப்படின்னா SI யூனிட்ஸ். ஓகே, இப்போ இந்த கிளாஸ்ல நம்ம SI யூனிட்ஸ்னா என்ன, ஓகே, என்னென்ன SI யூனிட்ஸ் இருக்குது, அதுக்கு எப்படி நம்ம டைமென்ஷனல் ஃபார்முலா எழுதுறது அப்படின்றதுதான் நம்ம பார்க்க போறோம். ஓகே, இப்ப based on the physical quantities, based on the physical quantity, நம்ம units two types classify பண்றோம். Okay, first one basic unit or fundamental unit. Basic unit or fundamental unit. Then second one derived unit. Second one derived unit. Okay. So in the basic units or fundamental units la 7 important categories இருக்குது. Okay, so 7 important categories இருக்குது. So simple physical quantities define பண்ணோம் அப்படிங்கும்போது நம்மளுக்கு ஒரு 7 quantities நம்ம ஈஸியா யூனிட்ஸ் கொடுத்து மெஷர் பண்ண முடியும். சோ அது மட்டும் இல்லாம ஒரு ஹையர் ஆர்டர் போகுது அப்படிங்கும்போது நிறைய வால்யூம், ஏரியா இதெல்லாம் மெஷர் பண்ணணும் அப்படின்னா இந்த பேசிக் யூனிட்ஸ்ல இருந்து தான் நம்ம என்ன கால்குலேட் பண்ண போறோம்னா அந்த குவான்டிட்டிஸ் எல்லாம் டிரைவ் பண்ண போறோம். சோ பேசிக் யூனிட்ஸ்ல இருந்து டிரைவ் பண்ணக்கூடிய அதர் யூனிட்ஸ்க்கு என்ன நேம் அப்படின்னா டிரைவ்டு யூனிட்ஸ். ஓகே, பேசிக்கா 7 யூனிட்ஸ் இருக்குது. அந்த 7 யூனிட்ஸ்ல இருந்து டிரைவ் பண்ணக்கூடிய அதர் பிசிக்கல் குவான்டிட்டிஸ நம்ம எதுல கொண்டு வரோம் அப்படின்னா டிரைவ்டு யூனிட்ஸ்ல கொண்டு வரோம். ஓகே, சோ பிசிக்கல் குவான்டிட்டிஸ வச்சு நம்ம யூனிட்ஸ ரெண்டு கேட்டகரியா டிவைட் பண்றோம். ஃபர்ஸ்ட் ஒன் பேசிக் யூனிட்ஸ் ஆர் ஃபண்டமெண்டல் யூனிட்ஸ். சோ இதுல மொத்தம் எத்தனை வெரைட்டிஸ் இருக்குது? 7 வெரைட்டிஸ் இருக்குது. ஓகே, சோ பேசிக்கா சிம்பிளா இருக்கிற யூனிட்ஸ வந்து நம்ம இந்த 7 யூனிட்ஸ் வச்சு மெஷர் பண்ண முடியும் பிசிக்கல் குவான்டிட்டிஸ. சோ ஒரு ஹையர் ஆர்டர் பிசிக்கல் குவான்டிட்டிஸ் போகுது அப்படிங்கும் போது இந்த 7 குவான்டிட்டிஸ நம்ம யூஸ் பண்ணி தான் அந்த ஹையர் ஆர்டர் யூனிட்ஸ நம்ம என்ன பண்ண போறோம்னா மெஷர் பண்ண போறோம். சோ அப்படி மெஷர் பண்ணி நம்மளுக்கு கிடைக்கக்கூடிய யூனிட்ஸ் தான் என்னது அப்படின்னா derived units. Okay, clear students, what is the difference between basic units and derived units? Now it is okay. Okay, fine. Next one, we can go for the 7 fundamental units. 7 fundamental units. First one, length. First one, length. Length can be measured by the SI unit meter. Okay, so simply we are writing the letter small m. Then second, mass. Mass can be measured by the unit kilogram. Kilogram. So it is simply written as kg. Then third one, time. Time is measured by the unit second. It is simply written as small s. Okay. So now write the dimensions. Okay. So dimensions, which is nothing but if you are taking the first letter of all these things. Okay. For the length, it is for the dimensional formula, we are written by the symbol L. Then for the mass, the corresponding dimensional formula, that is M. And time, the corresponding dimensional formula, that is T. Okay, so these three are very, very important to write the dimensional formula. Okay, length, mass, time. Then fourth one, temperature. Temperature is measured by the unit Kelvin. It is represented by K. In dimensional formula, we are using K or theta. So temperature is measured by how many units? Put it in the comment box, children. Kelvin, sometimes Celsius, right? Then fifth one, current. Fifth one, current. Current is measured by the unit, that is ampere. Okay, it is simply written as A. So for the dimensional formula, you are writing I or A. Okay, right. For the length, if you go for the running race and all, we are measuring it the length, no? So that length, it should be measured by the unit meter. The corresponding dimensional formula is L. Then mass, if you go for a vegetable shop, buying some vegetables, okay, so everything should be weighted by kilogram, right? So the dimensional formula for mass is capital M. And time for daytime, day, month, year, and all calculated by second. Okay, so this can be written by the dimensional formula, that is capital T. Then for a temperature, it is measured by the unit K. Okay, then for a current, okay, so current can be measured by the unit, that is ampere. So if you are taking a small wire or larger wire, okay, so if the current is passed through the wire, everything should be measured by the unit, that is ampere. Okay, these are all the 5 fundamental units. Then the next sixth one is luminescence intensity. Luminous intensity. So this can be measured by the unit, that is candela. This can be measured by the unit candela. So simply you are writing C, D. Okay. Then seventh one is amount of a substance. Amount of substance. So this is mole M. Okay. So the dimensional formula for this is simply you are writing mole. So luminescence intensity. Okay, so light can be measured by the unit, that is candela. So if you are using bulbs, okay, incandescent bulbs and various bulbs and all, we are used in a home or laboratory. So each can be measured by the unit, that is candela. Okay, light intensity can be measured by the unit candela. Right. In chemical laboratory and all, they are using some substances for making weights. So this should be measured by the unit, that is mole. The amount of a substance is measured by the unit, that is mole. Okay, right. So these are all the 7 fundamental units. Next one. We can go for some examples. Okay. So here 80 dimensional formulas are there. Okay. So these are all very, very important for the examination purposes. So we are just deriving one by one. Okay. Right. So luminescence intensity or SI unit, that is candela. Okay. CD. Okay. CD. Then next one, we can go for some more example. So we just split it into 5 parts. Okay. So first one, serial number. Second one, various physical quantities. And third one, formula. First one, area. Okay. Right. Say for example, if you want to measure the area of the road. Okay. First thing, measure the length. Right. Then next one, measure the breadth. Okay. So for a simple example, we are taking it as a road. Okay. So I want to know the total area of the road. So first I will measure the length unit. Then second one, I will measure the breadth unit. So area can be measured by the unit That is formula A is equal to length into breadth. Okay. So length can be measured by the unit what? It is meter, right? Simply breadth can be measured by the unit that is meter. Okay. So meter into meter, that is meter square. Meter into meter, that is meter square. For the length, it is measured by the unit meter. So the dimensional formula is capital L. Meter ku dimensional formula, that is L. So here meter square. So it is length square. So this is the dimensional formula for area. Okay. So simply we are writing that is length. Length oda SI unit, that is meter. Length oda SI unit oda value, that is meter. இதோட dimensional formula எப்படி எழுதுவோம்? Capital L. Right? So length அதோட measuring unit, that is meter. So breadth அதோட measuring unit, that is meter. Meter into meter, that is meter square. So meter square, we can write it as a L square. Okay. It is easy to understand, children. Say yes or no. Put it in the comment box. Okay. Next, second one, it is volume. Second one, it is volume. Volume can be calculated by the formula, that is L into B into H. L into B into H. Right? So length, we are calculating the unit, that is meter. Similarly, breadth, it is meter. And again, height, it is meter. Okay. Suppose for the example, we are taking TV. Okay. So the length, that is here, we are taking it as a length, breadth, and height. Okay. Length, breadth, and height. Say for a cubical structure also, we are taking the example. Okay. Length, breadth, and height. So formula for volume is length into breadth into height. So meter into meter into meter. Okay. So here we are writing the SI unit for the volume as meter cube. So now write the dimensional formula, that is here meter can be written by, that is the length L. So here meter cube no, so we are writing L cube. Okay. Then next one, we can go for the example. Okay, next one, we can go for an example. Another example, that is distance. Distance distance can be measured by the unit, that is meter. Okay. So readily write the dimensional formula for meter is L. Okay. Next one. Fourth one. Speed. Speed or velocity. Speed or velocity. So this should be represented by the formula, that is S is equal to distance. Distance by time. Distance by time. So here distance should be measured by the unit, that is meter. Okay. Then for time, it is measured by the unit second. Okay. Simply we are writing the another form, that is meter second power minus 1. Okay. So denominator இருக்கிற numerator நம்ம convert பண்ணும்போது S inverse. Okay. S inverse. So what is the formula for speed? Speed is calculated by distance. Okay. Distance by time. Distance is measured by the unit, that is meter, and time it is measured by the unit second. So simply we are writing the formula, that is meter second power minus 1. Now we are writing the dimensional formula. Okay. Dimensional formula, how will you write? For meter we are put it L, and second it is T power of minus 1. Okay. So this is the dimensional formula for speed or velocity. Okay. Speed or velocity. It is easier, children. It is easy to follow. So in the simple units எழுத தெரிஞ்சிட்டாதான் நம்ம next higher order போகும்போது இன்னும் கொஞ்சம் ஈஸியா problems எல்லாம் solve பண்ண முடியும். Okay. Yes. Next one, acceleration. Okay, next one, acceleration. Acceleration or acceleration due to gravity. Due to gravity. Okay. So in vehicle and all, we are known that there is an accelerator, right? So initially we are moving one speed. If you want to increase that speed now, we are using that accelerator, right? So change in velocity. Okay. So change in velocity by time, which is nothing but acceleration. Okay. So acceleration should be defined by the formula that is A is equal to B minus U by T. B minus U by T. Okay. So here U, which is nothing but initial velocity, and V, which is nothing but final velocity, and here T, which is nothing but our time. Okay. T, which is nothing but our time. So here acceleration is returned by the formula that is change in speed. Change in speed by time. Okay. We are all very well about the dimensional formula and formula for speed, right? So formula for speed is here meter by second, right? Then for the time, it is measured by the unit that is yes. So simply we are solving. So meter by second into meter by second into second. That is meter by second square, or we are simply written it as meter second power minus 2. Okay. Right. So acceleration is calculated by the formula that is V minus U by T. So here V minus U represented as change in speed and T represented by time. U, which is nothing but initial velocity, and V, which is nothing but final velocity, and T, which is nothing but time. Okay. So speed is measured by the unit that is meter by second. Then time, it is measured by second. Okay. So put it into the denominator, that is M divided by S into S, which should be is equal to M divided by S square or meter second power minus 2. Now, anyone tell me about the Dimensional formula for acceleration. I will give you the formula in SI units. Okay. Let us try about the dimensional formula for acceleration. Okay. How will you write? Very good. It is L T power minus 2. L T power minus 2. For meter, we are writing length, and for second, we are writing time. Okay. L T power minus 2. L T power minus 2. So the dimensional formula for acceleration is L T power minus 2. Very good. So next, we can go for another example. Up to this clear, children? So these are all very fundamental. If you clearly known that now, further simplifications will be very much easier. So that only I can handling very slow. Okay, you are convenient with that? Yes, fine. Next one, force. Okay, force should be simply written by F. Okay, so here we can write the formula for force and tension. First, write it the formula. Okay, first write it the formula. F is equal to M into A. So this equation is given by the scientist whom? Is any other idea? Yes, this formula will be given by the scientist, that is Newton. Right. F is equal to M into A. Right. So already we are known the formula. Okay. SI unit formula, we are known for mass and acceleration. So for the mass, we are writing the SI unit, that is kg. Then for acceleration, that is small a, it is measured by the unit, that is meter second power minus 2. So simply we are put it in the formula, that is kg meter second power minus 2. So this is the SI unit formula for force. Okay. Now we are write it in a dimensional formula. Okay. Right. How will you write the dimensional formula for kg meter second power minus 2? For kg, we are writing M, and for meter, we are writing L, and for second, we are writing T. Okay. So here we can have the power, that is minus 2. So this is the dimensional formula for force. Okay, that is M L T power minus 2. Okay, very good. Next. Seventh one. Density. Okay. Density. So first we can see about the formula for density. Okay. So what is the formula for density? Is anyone known? That is mass by volume. Okay, density, it should be represented by the symbol that is rho. So rho, which is nothing but mass by volume. Mass by volume. So here mass should be written it as kg and volume should be written by meter cube. Mass unit kg, volume it is meter cube, or otherwise meter cube denominator numerator we can convert. Okay, so kg meter power minus 3. Right. Now we are writing the dimensional formula. For kg it is m and meter cube it is L power of minus 3. Okay. Right. Density, it is measured by the formula that is rho is equal to mass by volume. Mass should be written it as kg and volume it is meter cube. So kg so kg by meter cube or kg into meter power minus 3. So the dimensional formula for kg meter power minus 3 is m L power minus 3. Next one, pressure. Okay. First one, we are writing the formula that is pressure should be written it as F by A. Okay. That is nothing but force by area. Force by area. So already we are known the formula for force. Okay. So force, that is M into A divide by area, that is meter cube, then kg meter second power minus 2. For mass, it is kg, and acceleration, it is meter second power minus 2. Then here we can write it as, sorry, it is meter square. It is meter square. Area, just meter square, meter square. Then we just cancel it, meter, meter. Okay. So what will you get? Kg second power minus 2 divided by meter. So simply we are writing kg meter power minus 1 and second power minus 2. We just bring it the m into the numerator. Okay. So now tell me the dimensional formula for pressure from this formula. Let us try. For kg, it is m, and meter, it is L power minus 1, and second, it is T power minus 2. Right? So this is the dimensional formula for pressure. This is the dimensional formula for pressure. M L power minus 1 and T power minus 2. Okay. Next one, we can go for a interesting one, that is work. Okay. Work can be written by the formula, that is force into displacement. Force into displacement. Okay. Force into displacement. So in physics, the formulas are very, very important. Okay. So here we are using many number of formulas which will be collected from 11th standard as well as 12th standard. Okay. So you should recollect once again. Okay. Force into displacement. This formula is very, very important formula. Force into displacement. Already we are known the formula for force. Okay. What is the formula for force? In SI unit, that is kg meter second power minus 2. Okay. Kg meter second power minus 2 into displacement, which is nothing but smallest length. So length, it should be measured by the unit, that is meter. Okay. So now we can combine it M and M. So kg, meter square, and second power minus 2. So now write the dimensional formula, that is meter ml square t power of minus 2. M L square t power minus 2. So this is the formula for work. So this is the formula for work. Dimensional formula for work. So this is the very, very important formula. Next, we can go for the energy. Okay. Next, we can go for the energy. So in energy, that is potential energy, kinetic energy, all the energies. Okay. All the energies having the same unit, that is same dimensional formula, that is ml square t power of minus 2. Okay, work and potential energy and kinetic energy. So all these things. Then heat energy, then rotational energy. Okay, rotational energy, pressure energy, then internal energy. All these energies having the same formula and dimensions. So what is the dimensional formula for work? Work, potential energy, kinetic energy, heat energy, rotational energy, pressure energy, and internal energy. They are asking now. Readily we are using the formula, that is force into displacement. The one thing you should be keep in mind now, we are deriving all these things easier. Okay. So this force into displacement is very, very important to derive the dimensional formula for work, potential energy, kinetic energy, heat, rotational, pressure, and internal energy. Right. Next one, momentum. Next one, momentum. Okay. Momentum should be written by the formula, that is P is equal to M into V. So this is the formula. Now we are writing the formula in SI units. That is for mass, it is kg, and V, which is nothing but velocity. Okay. That is meter second power minus 1. So now we write the dimensional formula for momentum, that is in kg we are writing m. Okay. Then for meter it is L, and for second it is T power minus 1. So that is the dimensional formula for momentum. So this is the dimensional formula for momentum. That is the mlt power of minus 1. So it is easy, children. Say easy or tough. Yes. So these are all the very, very simple concept. Okay. Next, we can go for another example. Next one, stress. Okay. So many people, they are using in that world, in this word, that is stress. Okay. So stress, which is nothing but it is a one kind of pressure. Okay. So stress can be written by the formula, that is simply I written it as a S1 should be is equal to F by A. F by A. So here F, which is nothing but force, and A, which is nothing but area. That is force by area. See, anyone write it in the dimensional formula for force and area? So simply we are written it as a mlt power of minus 2 divided by, that is, so here that is meter, right? Meter square. So now we are writing the formula for this force and area. So kg meter second power minus 2 divided by, so here that is meter square. So meter we just cancel out. So remaining kg second power minus 2 and m power minus 1. Okay. So now we are writing the dimensional formula, that is m L power minus 1 and T power of minus 2. Okay. So this is the formula for stress. So this formula will be seen already. Okay. So stress and pressure having the same dimensional formula, that is m L power minus 1 and T power of minus 2. Okay. Next one, strain. Next one, strain. Next one, strain. So this should be written it as S2. Okay. So strain, which is nothing but change in length by the original length. Okay. So del L by L or del A by A or del V by V. So there is a change in length, change in area, and change in volume. Okay. So here there is no dimension and no unit for strain. Okay. Now we are writing the Young's modulus. We are writing the formula for Young's modulus. Or bulk modulus and rigidity modulus. Rigidity modulus. So simply we are written it by the formula that is S1 by S2. So here previously I mentioned it that S1 should be stress. That is stress by strain. Stress by strain. Stress already we are known the formula, and strain there is no unit. Okay. For stress we are having the formula that is F by A, and for strain we are writing the above formula that is del L by L or del A by A or del V by V. Okay. So here there is no dimension or no unit, and here we are already calculate the formula that is meter, sorry, M L power minus 1 and T power of minus 2. So now tell me the dimensional formula for Young's modulus is dimensional formula for Young's modulus, bulk modulus, and rigidity modulus is simply we are written it as M L power minus 1 and T power of minus 2. We are just taking only the stress quantity alone. Okay. No need to worry about the strain part. So stress already calculated, that is M L power minus 1 and T power of minus 2. Okay. So readily we are writing the formula for stress na. We can calculate easily calculated the dimensional formula for Young's modulus, bulk modulus, and rigidity modulus. Okay. Okay, children, up to this clear? If you have any doubts means you can ask me now. It is easy to follow. So first 1 or 2 clauses will be very slow. Suppose if you want to recollect all these simple definitions and all, for this purpose only, we are taking very slowly. Then further classes, it will be go little bit faster. Okay. So these formulas are very, very important. And this should be collected from the NCERT books. So from the basic, you should be strong now. We can solve many critical problems and all. So that only we are going very smoothly. Okay. Okay, children. Thank you. We meet it in a next class.
Students, next class உங்களுக்கு நாளைக்கு டைமிங் நாங்க வாட்ஸ்அப்ல இன்ஃபார்ம் பண்ணுவோம். அடுத்து வந்து பயாலஜி கிளாஸ் 5:15க்கு